Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Broken Windmill by Aaron Leday, or a Spartacus, a Spartacus, a Spartacus, okay? I'm assuming it's basically sort of referencing Spartacus with an aspartame beginning? I don't know. Anyways, let's get to the rules. We have Sudoku, where we need to fill each row, and get a row, column, and region with the digits 1 through 9. We have arrows, where digits on an arrow sum to the digit in the circle of that arrow. So, for example, if this were, say, a 3 and a 5, this would have to be 8, because these two digits must add up to the digit that's in the circle. And we have double arrows, where digits on a line sum to the sum of the two digits at the end of the line. So these 5 digits must sum up to the digit that's here and the digit that's here. So you could have something along the lines of, say, like 1, 2, 4, 3, and 7, and this would be 9, and that would work because these 5 digits add up to 17, and 8 and 9 add up to 17 also. And all double arrow lines are straight. So it doesn't do anything funky like go across here and then go back here. It must be a double arrow line going this way, a double arrow line going that way, again this way, and then this way. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. So basically, we have this digit is counted 4 times, and every other digit here is counted once. That equals the sum of these 3 digits, and these 2. Okay. Well, this is at least 1 through 5, adding on the line. So that means these digits must be adding up to at least 1, 2, 3, 4, and 5, which is 15. So you have to have 6 through 9 here. 6 through 9. Same with this. You have 6 through 9 here, and 6 through 9. That means these must be an odd and even pair, and these must be an odd and even pair, because the sum of these 5 digits equals the sum of these 2. We are guaranteed, so to add, they add up to 16, 15, 16, or 17 here, because that's the most that 2 digits can ever add up to. This has to be 1 through 6 here to add up to at most 9, because you could have 1, 2, and 6 to add up to 9. These have to contain the digits. It can be 1 through 7 here. And we're guaranteed you have 1, 2, 3, and 4 and 7 is the highest digit to add up to 17. So you have to have 1, 2, and 3 here, which means the remaining digits in the row must be 4 through 9. So this adds up to 15 to 17. We know these are the digits 1 through 9, so that adds up to 45. Nine has... Okay, so these are the digits 1 through 7 also. And the remaining digit in... So 7 could be here. 1, 2, 3, 4, 1, 2, 3, 4. We know one of these has to have an 8 and a 9. This is 4 through 9 here and 4 through 9 there. So you would have, if you have an 8, you cannot have 9 and 8 on the same diagonal, right? If you had 9 here, that would mean this is at minimum 9 plus 1 and 2. Right, so so you have to have, okay, you have to have 8 and 9 on these diagonals. Can you ever have 8? Can you ever have 9 with 7? And the answer would be no, because 9 and 7 would require this to be 1, 1, and 1 at least. And that would be too large, right? 9, 7 is 16 plus 3 ones is 19. And 2 digits can never add up to 19. You can only add up to 18 at most. So this can never be a 7 here. Yeah. Can you ever have 6 here? I think the answer to that is no also. Well, let's do the sums of these digits. I think that might be more prudent. These are the digits. So these are the digits that add 1 through 9. So that's adds up to 45. You have 1, 2, 3 here. 1, 2, and 1, 2, 3 at minimum. So that's 6, 6, and 3, which is 15. 15 plus 45 is 60. You have at most 7, 8, 9 here for the circles, 7, 8, 9 here for the circles. Let's use a calculator because I don't want to... 7 plus 8 plus 9 is 24 times 2 plus 17 is 65. And the problem is this has to be counted 4 times. So not including that being counted 3 more times, this has to be 45 plus 6 plus 6 plus 3 is 60. And then you have plus another 3. Because this has to be... So if this is 1 and it's counted 4 times, then you can get 63. What happens if you count 2 3 more times? You get 66, which is too large. So this has to be a 1. But then that changes what this sum is. So 1 eliminates 1 from being there. No 1 here. This is 2, 3 at minimum. So then you'd have 45 plus 3 for the other ones, plus 6 plus 6 plus 2 plus 3 is 65 exactly, which is the maximum amount these circles can be. So this must be the maximum amount. So this has to be 7, 8, 9 as a triplet. This must be 8 and 9 here as a pair, which eliminates 8 and 9 in the rest of the row. And this must be 7, 8, 9. And this has to be 1 through 3 here. That's the minimum. This has to be 2 and 3 here. That's the minimum. And this must be 1 through 3 here. And again, 1 cannot be here. So this is 2, 3, 2, 3 as a pair, which eliminates 2 and 3 in the rest of the row. Or column. We have a 4, 5, 6, 7 quadruplet. So this is guaranteed to be 6 here. To add up to 17, that means these must be 11. So since these add up to 11, these also must add up to 11, because if you remove 4, 7 here, 5, 6 has to be here. If you have move 5, 6 here, 4, 7 has to be here. So this also must be 8 and 9 as a pair, which means that removes 8 and 9 in the rest of the column. We have a 4, 5, 6, 7 quadruplet in box 5, so this must be 2, 3, 8, 9 remaining here. This 1, 2, 3 triplet here eliminates 1, 2, 3 in the rest of the column, so no 1, 2, 3 here. This is 4, 5, and 6 to add up to 8 or 9. If you have a 4, 5, and 6 here, the remaining digits must be 1, 2, or 3. So we're guaranteed this has to have a 1 here, because we have a 1, 2, 3 triplet in the box, and the 1 can only be here now. So this is either 1, 2, 6, 1, 3, 5, or 1, 2, 5. I guess it could be 1, 3, 4 also. So that's possible too. So these, we'll mark these as orange. These must be the yellow 4, 7, or 5, 6 pair. That makes these orange, and these have to be yellow. This cannot have 2 or 1, 2, or 3. This cannot have 1, 2, or 3. So this must be 4, 5, 6, 7, or 8. This cannot have 1, 2, or 3 because of the 1, 2, 3 triplet here. So this has to be either 4 and 4 or 4 and 5, adding up to 8 or 9. One of these, though, is guaranteed to be a 4. This can't be 1 through 3. This can't be 1 through... Okay, so these have the same problems. So this is 4, 5, or 4 and 4. And this is 4 and 5, and 4 and 4. Well, we have a 4, 5, 4, 5 pair in column 3. That eliminates 4 and 5 in the rest of the column. So this is 6 through 9, 6 through 9, 6 through 9, 6 through 9. This cannot be 7, 8, or 9 because of the 7, 8, 9 triplet in the row. So this can't be 7, 8, or 9. It's 6. That eliminates 6 here. There's no 6 here. There's no 6 here. Let's see. We don't have anything. We do have something in row 3. So that's 6, 7, 8, 9, 6, 7, 8, 9. 6, 7, 8, 9 again cannot be 7, 8, 9 because of a 7, 8, 9 triplet in the column. So this is 6, which makes this 7, 8, 9, 7, 8, 9, and 7, 8, 9. Okay. This is going to be the opposite of this. So let's mark this as blue. That's not helpful. Let's do this one. We'll make that green, and we'll make this red. That's not helpful either, because... Green, this is the red one. So one of these combinations, so if this is 9, this is 4 and 5 as a pair, and this is 8, which makes this 4 and 4. So then this would have to be 5, and that would be 4. If this is 9, this is 8, and that's 4 and 4. So this would have to be 5, and that would be 4. So either way, this is 9, it looks like. Right? Because if this is 9, we have 8 here, so that's 4 and 4, so that forces this to be 5, which makes that 4 at minimum. 4 and 5 add up to 9. If this is 9, this is 8, that's 4 and 4, which makes this 5, and therefore 5 plus 4 is 9. So either way, this is 9. This is 8. That means this is 1, 2, 5, or 1, 3, 4. So this is 4, 5, which means in column 7, we have 6, 7, 8, 9 as a triplet, or as a quadruplet, because we have 4, 5 as a pair here. This can't be 7, 8, and 9 because of the 7, 8, and 9 triplet in the row. So this must be 6, which makes this 7, 8, and 9. 8 eliminates 8 here. No 8 here. This must be 7 or 9. And this must be 7, 8, or 9 here. So one of these is a 5. So these are opposite sets. So again, we'll make this green, we'll make this red. This must be red here then. We don't know if both of these are red or if this is 9. Hmm. 6 has to be one of these 2 digits. This can't be 9 because of 9 in the box. No 9 here, no 9 here. So one of these is 9. That means one of these has to be 1 here because one of these is 1. This has to be 4, 5, 6, 7, 9. Obviously no 6 there. Remaining digits of column 2. We have 1 through 6. And this can't be 6 because of 6 in the box. 1 through 6, no 1 here. This is 2 through 6. No 1, 2, 3 here. This is 4, 5, or 6. And 1 through 6 there is a possibility. So this 4 and 5 means that they see these cells here. So this cannot be 4 or 5. There's no 4 or 5 here. This is red, so this must be green here. Remaining digits of row 2 and 8 have to be 1 through 5. Remaining digits of column 8 are 1 through 5. And remaining digit of box 3 is 1 through 5. Remaining digit of box 1 is 1 through 5. Because we have a 7, 8, 9 triplet here. Same here. This green digit is either here or here in box 6. Okay, so this 4, 5, the green 4, 5 cannot be any of these. So it's either here or here, or it's here or here. Um, One of these, I think, has to be 7 and 7, right? If this is 7, that would force this to be 9, 8. And therefore, this would have to be 7 here on the other end. So that means one of them adds up to 14. Can it ever be 9? 9, 1, 2, 1, 1. I think that's possible, actually. Um, hmm. Yeah, one has to be on both ends. So that would give you 1, 1, and 1. That's 3. We know we can't have 2 and 9 on the same... Sorry, 9 and 8 on the same column. Or same diagonal, I should say. Um, hmm. These 2 and 3s are going to be different. So let's mark this as, I don't know, dark. And we'll make that medium. So then this must be dark here. Dark has to be one of these two. Hmm. Medium cannot be either of these, so it has to be one of these two. And then it has to be one of those two. Hmm. If one is here, that means one cannot be either of these, so one has to be there. If one is here, it's the same thing. So then you have guaranteed 1, 1, and 1. You can have at most 3 and 9 here. That would be 12. Because you can't have 8 and 9 there because that's too big. 17 plus 3 ones is 20. 3 and 9 is what? 12? Plus 3 ones is 15, which would require a 7 and an 8 here. But then that would eliminate all possibilities for that cell. So therefore, this must be 2 and 9 adding up together and 3 and 8 adding up together. But we don't know which one's which. So I guess we mark these as blue and these as, I don't know, pink. So either if this is 1 and this is 1, it has to add up to 2 and 3, right? On the other side. Hmm. Okay. Right now, I don't know what the differentiator here is, though. Green is one of these three. So we have red here, so one of these three is red. Hmm. And that's not too helpful. Hmm. Okay. If green is here, that means the yellows have to be green, so then this would be green. So if we had green here, so if this were green, this would have to be green here, and this would then be green, which would mean green would have to be here, green would have to be here, and green would have to be here. Okay. And then obviously green would be there. If this is red, this would have to be red to add up to 9. So we'd have red and red. Red can't be here. Red would be one of these two. So this would not be red. So this would have to be green in that instance. So green is one of the oranges, which means green would have to be here. Okay, so let's go through the scenarios then. If this is green, that means green cannot be here or here. Green is part of the yellow. Green therefore would have to be here, which means green couldn't be here, so green would be there. Since this is opposites, this must be green, so that would be green there. So we'd have green here, no green here, no green here, so the green would have to be there, which means green couldn't be any of these cells because of green in the boxes, and this can't be green, this can't be green, so the green would have to be here, which would force this to be green there. If this is red, that means this is 8. This would be 9, so this would have to be red here. So this couldn't be red, this would be green. So you'd have green here, green here. One of these would have to be green, so it would have to be here, which would mean green couldn't be here, green would have to be here. So you'd have green here, green here. Green would have to be one of these two. You'd have green. Green would be not here, not here, so it'd have to be here, which would mean it would have to be there. So green would have to be there again. So you'd have red and green. Okay, let's do the other way too. Okay. So that would be green, 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 green. Where would red be? Red would have to be here. So red would be one of these two. Green would be yellow, so red would have to be orange, which means red would be here. Red would be one of these two. Red could not be here, could not be here. Not here either. Doesn't really restrict too much. Okay. So you'd have red here. Red is one of these two. Red here. Red would have to be one of these three. No red here. Red would be one of these 4. What happens if... So, okay. So these are... One of these, at least, is... Okay. So let's not... let's remove the unknown greens. We know one of these two is a 4. So that means 4 cannot be here, 4 cannot be here. We know one of these two is a 4, so 4 cannot be here, 4 cannot be here. Similarly, these two are... One of these two is 4, so 4 cannot be here. That's interesting. This cannot have a 4 either for the same reason. So this could be 1, 2, 3, 5, 6, 7, 8, 9. Yeah, it's pretty broad. Okay. But what happened? Okay, so again, if this is green, that means yellow has to be green. So therefore green has to be here because this can't be the 4, 5 there. These would both have to be green. So then this would be red. Green couldn't be here, here, or here, so green would have to be here. Green couldn't be any of these, so green would have to be here. Green couldn't be here or here, so green would have to be there. And that would be all the greens. Where would red be? Red could not be part of yellow, because that's the green 4, 5. Which means this couldn't be red, so red would have to be there. And then we don't know about the rest. Oh, that's interesting. If this is 4, 5, this becomes 1, 2, 3 as a triplet. Huh. What does that mean? Does that mean anything? I'm not really sure. If this is red here, if this is red, then this has to be different colors, so this must be red here. So that's really if green is a 4 or red is a 4, right? Oh, that's interesting. So if this is, again, green, this is 9, so this must be 8, so that must be 4, 4. And then this would be 4. If this is both red, then this is also 4. So either way, this is guaranteed to be a 4. That's interesting. So this cannot be 4 here. This can't be 7 then. There's no 4 here. So either way, this is a 4. I don't know about this then. If this were green, then this would be green, green, and that would be 4. If this is red, that's 4, 4, and this would have to be green and red, which is a 4. So this is also a 4, which makes this 5, so this must be 1 and 2 as a pair, which eliminates 2 in the rest of the row, so no 2 here. 5 eliminates 5 here, which means this can't be 6. It eliminates 5 there, which means this can't be 6. This 4 eliminates 7 there. So this is 4 also. This is 5, which eliminates 5 in the rest of the box. This is 1, 2, and 3, so this can't be 2 because of the 1, 2 pair in the row. 3 eliminates 3 here, so that's 2, which eliminates 2 in the rest of the column. This can't be 3. Okay. So that's not too helpful there. Anyways, 2 can't be here because of 2 in the box. We know 2 is one of these 2 digits here, which means the 9 must add up with it. So if this is 2, that's 9. If this is 2, that's 9. Either way, then one of these is a 9. So this cannot be 9 here. We also know that one of these 3 is a 9. So I guess we should have been able to figure that out anyways. Huh. Oh, I guess this could have been... No, that's an 8 already. So yeah, one of these is 9. So, huh. Should have been able to figure that out. Which means this would have been 1 and 2. We got there anyways, so it's fine. Huh. Interesting. This can't be one. Oh, this 1, 2, 3 triplet eliminates 1, 2, 3 in the rest of the row. So no 1, 2, 3 here, no 1, 2, 3 here. Remaining digits are 6 through. This 4 eliminates 4 here, so this is 5, which eliminates 5 here. 5 eliminates 5 here, so that's 6, which makes this not 5 or 6. It's 7, 8, or 9. This is 7, 8, or 9, and this is 7, 8, or 9. 6 eliminates 6 here, so it's 3, which eliminates 6 and 3 here. It's 1. That eliminates 1 and 3 in the rest of the column. And 6. So this is 2, 4, 5 here. Okay. We have 5 here, 5 here. This can't be 4, 5. We have 7, 9 as a pair here, so that can't be 7 or 9. So it's 4, which eliminates 4 here. This can't be 4. It's 6, 7, and 9. We have a 6, 7, 8, and 9 quadruplet, which makes this 1 through 5. No 4 here because of 4 in the box. No 4 here because of 4 in the row. This can't be 5 because of 5 in the box. Hmm. 4 eliminates 4 here. So all the greens are 5. So all the greens are 5. All the reds are 4. So 4 plus 4 equals 8. So that makes this 9. Which makes this 7. That 9. 7 eliminates 7 here. So it's 8 and that's 7. So this must be 1 and 1 here to add up with 2 and 9 or 3 and 8. So we have 1 here, 3 here, 1 here, and 2 here. So this is 5. Wait, 17 minus 5 is 12. So we have to have 3 and 9 here. That doesn't add up. Hold up. Did I miscalculate something? I must have, right? Oh, well, no, there's 4 lines. So that's times 3. Hold on. Okay. 1 plus 2 plus 3 plus... I'm so confused by this now. 2, that makes this 3, that's 2. I'm so confused. Let's add these up. Okay. So 7 plus 8 plus 9 plus 8 plus 9 plus 7 plus 8 plus 9. 65. 1 plus 2 plus 3 plus 2 plus 3 plus 1 plus 2 plus 3. 17 plus 45 plus 1 plus 1 plus 1. Because we have 1 here, 2, 3, and 4. What is going on? So I have 2 and 3 here. Maybe that was the problem. Well, but I know I have to have 2 and 3 here. Yeah, I think I kind of messed that up. Okay. But I think the numbers are still the same. So this has to be 1. We have to have 2, 3 here. No, because it's 5, right? Okay, never mind. Yeah, that's right. Oh, wow, you can go back to the to the clearing. That's good. Right, it's 3, 1, 2. Oh, it's 1, 2, 3. Okay, that's the reason why. So that's why it's so confused. This is 2, 1, and 3, which is 11. Sorry, 6. 17 minus 6 is 11, so it has to be 2, 9, and 3, 8. Okay. I kept forgetting the 1 being counted here. That's the reason why. Anyways, 3 cannot be here or here, so this is 8, 9 as a pair, which means this can't be 8 and 9. 4 and 5 eliminate 4 and 5 here, so that's 7, which makes this 4. So this must be 7 and 4 here. Therefore, this is 5, 6 as a pair. This must be 5 and 6 as a pair. 2 eliminates 2 here, so that's 3 and 2. 8, 9 as a pair eliminates 8 and 9 here, so it's 7. That makes this a 6, which makes this an 8. 7 eliminates 7 here, so it's 9, which means this can't be 7 or 9. It's 6. No 7 or 9 here, it's 8. No 7 or 8 here, it's 9. And no 8 or 9 here, it's 7, which makes this 9. No 7 and a 9 here, so that's 8, which means this can't be 7 or 8, it's 9. This can't be 9 or 8, it's 7, which makes this not 7 or 9, it's 8. Okay. 9 and 8 eliminate 9 and 8 here, so it's 7. No 3 here. No 2 here. These cannot be 5 because of 5 in the box. This is 1, 3 as a pair, which eliminates 1 and 3 in the rest of the row. So this is 2 or 5, 2 or 5. 1 eliminates 1 in the rest of the box. 2 eliminates 2 in the rest of the box. 1 eliminates 1 in this can't be 1 or 4. This can't be 4, and this can't be 4. We have a 2, 5 pair in box 1, which eliminates 2 and 5 in the rest of the box. This can't be 2, 3, 4, 5. It's 1. We have a 2, 3, 5 triplet in row 1, which eliminates 2, 3, 5 in the rest of the row. This can't be 5. It's 6, which makes this 5, which eliminates 5 in the rest of the box. So this is 1, 2 as a pair, which eliminates 1 and 2 in the rest of the row. So no 1. This can't be 4, so this is 3, which makes this 1, which makes that 4. No 2 or 3 here. It's 5, which makes this 2, which makes this 5, which makes that 2, which makes that 5. This can't be 5 or 3. It's 2, which makes this 3. 2 eliminates 2 here, so it's 1 and 2. Remaining digit in column 1 is a 3. 5 eliminates 5 here, so it's 6 and 5. This can't be 7 or 9. It's 8, which makes this 9. This must be 9 and 2, adding up to 11. So this is 2, which makes this 1, which makes that 2. That makes this 3 and 8 to add up to 11, with the 1, 2, and 3 adding up to 17, which 8 and 9 add up to. 1 minus 1 here is 3, which makes this 1. And the rest we get from Sudoku. This can't be 9, so this must be 6, which makes this 9. Which makes this 4, and this 7. Ugh. Yeah, I kept forgetting the 1 in the middle. So I was trying to add up something that wasn't quite there. Interesting little pattern. I messed up the execution, so that was on me. But yeah, this was not too bad. Hopefully you didn't mess up the execution like I did. But it's still not too bad. It's basically, the interesting part were these, really, right? And that this had to be 4 no matter what. This had to be 4 no matter what. And that changed what these could be, right? So that was interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.